Okay, so this problem is problem number 4 from chapter 5. So we have a speck of clay here, which is on the edge of a potter's wheel, and the potter's wheel is revolving around with the frequency of revolution of 45 revolutions per minute, and the diameter of the wheel is 35 centimeter. So based on the information we have, we want to find out the acceleration of this speck of clay here. Okay, so the first thing we want to do here is change the frequency to the angular frequency, which is also called angular velocity. And from the relation between the angular velocity and the radius of the wheel, we will get the actual linear velocity. And the next thing that we need to do is change the diameter to radius, okay? And based on the relation between the acceleration and velocity and radius, we should be able to find the acceleration. So let's go to next page and work on that. So the first thing is the frequency of revolution, right? So frequency of revolution, F, was 45 revolution per minute. So I'm gonna do 45 for 1 minute. So let me change this to seconds, okay? So 1 minute over 60 seconds. 60 seconds. All right. So if you convert this, you're going to be able to get 0.75 revolutions per second. So it's going to give me a 0.75 revolution per second. Okay? Per second. So the next thing that I want to do is I want to convert this frequency to the angular velocity or angular frequency, which is given by omega. I'm going to write down here angular velocity. Okay, we're just writing down the magnitude of the angular velocity, which is going to be equal to twice pi and f. So if you plug in the value of the frequency from above, you're going to get 4.712 radian per second. Radian per second. All right, so we have the angular velocity now. So we are going to convert this angular velocity to the linear velocity. So the next thing that we're going to do here is use this relation here, which is the linear velocity. Okay, linear velocity, which is denoted by V, is omega times r. So this r here is the radius. Sorry. So this r here is the radius of the wheel. Okay. So this is radius of the wheel. Now, if we go back to page 1, actually the diameter is given, which is 0.35 meter. Okay. So we will convert that to radius. So the radius r equals to d over 2 equals 0.35 meter over 2, which is going to be 0.175 meter. All right. So the radius is 0.175 meter. So based on that, we're going to get, so from there, v linear velocity equals omega r. Okay, therefore linear velocity v equals omega r, which is going to be 4.712 times radius, which is 0.175. So I'm going to do this. So the velocity is going to be in meter per second. So this is going to be 0.825 meter per second. 0.825 meter per second. Now we know the velocity and we know the radius of the wheel, so we can get the acceleration from here. Therefore, acceleration A r, just to make sure that is the radial acceleration, is v squared over r, which is going to be equal to, so plug in the value for the velocity that you get from here, which is 0.825, and the value for the radius, right? Square of the velocity divided by the radius, which is 0.175. So this should give you 3.9 meter per second square. Okay, so this should give you 3.9 meter per second squared. So this is our final acceleration.